let's get started, and I'll introduce you.
Right.
I'm really looking forward to this. So for those that don't know, or maybe they haven't had a chance to check out your profile, Maia Brenner is a passionate data scientist and economist with strong programming skills. She's also a mathematical and statistical background and work experience in consulting and the public sector. As an AI specialist at Trident she helps clients to utilize the full potential of data science and machine learning to solve their business problems. And Maia's experience in the consulting industry covers several projects related to demand forecasting, price optimization, customer segmentation, natural language processing, and others. She's also a professor and enjoys working on initiatives such as AI for social good. She's helped in the application of machine learning to improve the public education sector and is involved in in the inequality research groups as well. So we're really looking forward to your talk today, Maia. Thank you so much for joining us. And I will pass the mic to you.
Thank you very much, David, for the presentation. So as you said, I'm Maia Brenner. I'm currently working as AI specialist at Tyrolabs, but I like to introduce myself also as economist because that's kind of what I study, and I think that's pretty much related to the use case that I'll be presenting today. So today we'll be talking about how we help Tyrolabs luxury retailer boost its gross margin, increasing gross margin by 28%. So the agenda for today is I will briefly introduce what we do at Trident so that you get a better idea and context of where this use case and end-to-end experience comes into play. And then I will be also introducing kind of the theoretical background of our price optimization approach. And then I will dive into the end-to-end use case, getting to explain what's the algorithm, what's the data, and how we did the system and how we put it into production. And finally, I have some takeaways of how you could get started, either if you're coming from the data science world, if you're coming from business retail experience. I think there's a lot of things that you could be doing right now. So as I said, I'm coming from Tyrolabs. Tyrolabs is a machine learning consulting firm. I'm currently based in Montevideo, but we also have offices in San Francisco and Luxembourg. And we have been serving clients for more than 10 years in this helping them throughout this machine learning journey. So we help them since the inception of the idea, understanding whether their business problem can be solved with machine learning and AI technologies, till putting these systems into production, developing them, and making sure they adopted it internally. So right now, we are more than 50 people in the team, and we mostly serve clients in the US, but we also work with clients in other regions. So in terms of expertise, we like to divide our knowledge into these 3 domains, but obviously all of them are very much related. So we have applications in terms of computer vision, that's everything that has to do with video and images. Then we have expertise in natural language processing, understanding text and audio. And then we have a lot of other applications and expertise in predictive analytics. That's pretty much what I'm be focusing today on, our area of expertise regarding price optimization. But obviously, all these price optimization solution and machine learning as a whole gets to learn and combine computer vision, natural language processing, and other predictive analytics techniques. So in terms of the current pricing strategy, I always like to start on 2013, but it's not very recent if we think about it. But back at that time, Amazon was already performing more than 2.5 million price changes per day. And that was informally known as the Amazon effect, since Amazon changed to do these daily price changes, while most of their competition was doing monthly price changes. So this idea of changing prices dynamically in a daily basis was already being done several years back. And so if we move a little bit forward in time and we get into 2018, we see a survey from Bain & Company that concluded that top performers across industries, retail and other industries, were nearly twice as likely to price dynamically. So this idea of changing prices really often. But when we come into 2021, what I like to stop and think about, it's not about whether or not we should be applying this kind of dynamic pricing, but how to do it in an effective way. So it's not a matter of changing prices as often as possible, but it's about being able to set the correct price at the correct moment in time to the correct customers as to achieve some objective function we may have in mind. So in this case, we will be talking mainly about optimizing or maximizing our profit and deciding which are the exact price changes that we have to do in order to achieve this. So when we think about pricing with AI, and we can think about kind of this schema in which we have data coming from different sources in structured and unstructured way. So we may have information of our historical sales, but as I mentioned before, we may have images of our products, or we even may have video analytics, statistics of the amount of people going by our stores when they were open, obviously, but also we have everything that has to do with the text and description of the items we're selling and the reviews that could also be applied to an AI or machine learning algorithm or system. So having all this amount of data allow us to train this AI system and output a desired price. It could be the initial price in the sense, in the case that we don't have sold this item ever before. So this would be like a new item that we have to put on sale. Then we have the best price in the terms of being able to do an optimal price suggestion, or maybe defining the markdowns or the promotional prices we may be setting. So when we think of this AI system or machine learning approach, at Tyrolabs, we like to divide them into two groups. So we have, on one hand, what we call automated pricing systems. On the other hand, we have what we call price optimization systems. So in terms of automated pricing, and the main difference among the two of them, automatic pricing, we are trying to mimic and we are trying to copy the same pricing strategy that some pricing experts have already been testing out. While doing price optimization, instead of mimicking or copying what others have been doing so far, we are trying to change this strategy in order to look for one that may be better. So when we think about automatic pricing and how the machine learning model itself works, is by trying to predict what is the price that this item should have. So imagine we have this guitar, we have the images, we could have even the description of the guitar, and we may have a lot of historical sales of how this guitar has been sold, or if it's a unique item, some similar products that have been sold in the past. And so there may be an expert that would look at this information and define a price, and so we may be training a machine learning model to be able to predict that exact price point. So that would be a way of automatically price items, but we are not necessarily deciding on an optimal price to be suggested, right? So when we dive into price optimization, the whole point is to use data analysis techniques as to be able to understand the price elasticity of demand. And so for price elasticity of demand, what we understand is the sensitivity of demand. So how a change in my price will affect the amount of units I will be selling. So if I increase the price by 10%, how many units less I will be selling, and the other way around, right? And then once we have understood the price elasticity of demand, we may be interested in finding the best prices, as I said, to maximize an objective function. So the idea of the objective function, in general, we may think of maximizing gross margin or maximizing revenue, but we could also think of price optimization with an objective function of maximizing the sales velocity, or we could also think about maximizing the volumes we are selling. So the objective function at the end of the day is something that from the business perspective, we will be defining itself. So if we translate this business problem into a mathematical challenge, what we're observing is that we have a function, in this case the demand, that is Q, that will be depending on P, the price, times price minus the cost if we are trying to maximize the profit. So what we're going to be doing mathematically is to find the set of prices, that's the P, that will maximize the sum of all the profit obtained for each particular item. But obviously, this is an oversimplified version of the business problem itself, because demand, the Q function here, does not only depend on price, but depends on a number of other features. So you may be thinking about seasonality, the moment in the year in which you are selling, the competitor's price, or even you could be thinking of complementary products, substitute products that will definitely affect the amount of units I will be selling. So this problem looks way more like this mathematical formulation in which we have n amount of x variables, could be thought of features, that will be affecting the amount of units we will be selling. So at the end of the day, what we are doing when we are trying to estimate the demand function is to be able to estimate the demand curve. So if we set all the other features, parameters, or variables, covariates equal, and we only change the number of the price that we are setting, we will observe how the amount of units change. So by this, we can build this blue curve in which for each particular price, we can define what's the number of sales units we will be selling. And once we have been able to estimate the demand curve, estimating the profit is just a matter of a calculation. So if we have the Q function times price minus cost, we can get the profit function. And so if we are looking to maximize profit and we have no additional constraints or interdependencies, we would say, okay, the price to be set in this particular case is this particular price, since the profit hits the maximum in this curve. But obviously, as I said before, real problems are not that easy, and there are a lot of different constraints and interdependencies. So we have stock level constraints, we have dependent demands in which we have substitute products, we have complementary products, we have promotions going on, and we have a lot of other retail's additional goals that will make this a way more difficult optimization problem. But the whole point is to have first the forecasting model capable of estimating the elasticity curves, and then plug in those demand curves into an optimizer capable of defining the optimal set of prices given the constraints and interdependencies. So after all this theoretical introduction of what's price optimization, I will dive into this end-to-end use case. So in this particular example, I will be talking about a luxury retailer company that had more than 400 stores in 10 of the major airports, where they used to visit the stores more than 160 million travelers per year. Obviously not in 2020, not 2021 either. But a luxury retailer company wanted to start working on a price optimization project. So they came to us and we defined this project timeline. So this is a POC in which we wanted to start small, but start and measure and see the results that this kind of price optimization solution could have. So we decided to start working on a subset of products. So we process and understand the data in 4 weeks. Then we evaluated and selected the best fitting models for these particular products. And then we went into an online experimentation for the selected products on a 10 weeks timeline. So even though it says online experimentation, this was done on a physical store. So this experiment was taking place on a brick and mortar store in one of the airports, in which prices had to be manually printed and reprinted and tagged on the physical store. So for you to get an idea that price optimization and dynamic pricing does not only has to be taken place in an e-commerce, but could also take place on a physical store. So in terms of the experimental setup, as I said, we always have in mind this experimental mindset in which we have to measure and see the results. So we have to always work on defining what's going to be the experimental setup. So defining on what basis we will be doing the price changes. It could be hourly, daily, weekly, even monthly we could think of. Then we have to decide on what set of products will start the experimentation. Then what's going to be the time span for exploration and exploitation, and we will briefly introduce these two concepts shortly. And then we have to define how are we going to benchmark ourselves. So how are we going to compare ourselves to a control group. So in this particular scenario, we decided to go for a weekly price changes because, as I was mentioning, this was on a physical store. So prices had to be printed and we have to go into the stores and change those prices. So obviously, in terms of the logistics, we couldn't do prices more often, but we had weekly price changes. And then we decided to start experimenting with a set of products. So all of them from the same category, that was the beauty category. And we had more than 110 products being tested in this experimental stage. And then in terms of the time span for exploration and exploitation, we had to divide and have 5 weeks for exploration and 5 weeks for exploitation. And this trade-off exists when there are not enough price changes that have been historically tested in the past. So imagine that you're trying to estimate the demand curve for this particular dress, and for the whole history of your historical sales, you always sold that dress at the same price. So it's very difficult for the machine learning model to be able to extrapolate what would be the amount of units sold at a different price point that has never been tested before. So we had to balance this trade-off into going into full exploitation with the information we have versus having to spend some time doing some exploration. And we did so with an intelligent exploration strategy that allow us to define which are the price points that we think will provide the most information, valuable information, but also providing increases in the gross margin. And so finally, as I was mentioning, we need to say how we are going to be comparing and how are we going to be able to say we increase gross margin, right? So in this particular case, as I was mentioning before, this is kind of ideal scenario for an economist, and in which we have a control store and a treatment store that were completely independent because they were taking place in airports, so people couldn't travel from one another. And so we were very it was clear scenario in which we could compare with a different approach as to what's the new pricing strategy performing versus the business as usual or the way the business experts were pricing so far. And so this is the end-to-end system overview. So we had a bunch of different data sources. As you may see, they were all in Excel files. So it was not something super sophisticated in terms of data lake or data integration. We have the historical sales data. So how many units have been sold in the past and at which particular price those units were sold. Then we had market information regarding competitors' price, and for some products, we had even a metric of the market share of that product we had. Then we had information in terms of the currency exchange and a lot of information in terms of macroeconomic time series. So imagine about GDP, unemployment rate, and that kind of information. And then we also had everything that has to do with the calendar data. So everything that has to do with holidays, special events taking place, and we did a lot of feature engineering to being able to use that calendar information in a smart way, as like imagine how many days are left until next Black Friday, or that kind of feature engineering that we created. So with all this information, what we do is we predict, we train a machine learning model, and then there's the trade-off between training one machine learning model for all the different products, or maybe having to train specific machine learning models with specific products or categories. But this machine learning model would have the target variable, that's the amount of units to be sold in each particular moment in time, given the other features. And in particular, we work with an XGBoost regression model in this use case. And so from this machine learning model, what we get, as I was mentioning, is the estimation of the amount of units to be sold. In this particular case, it was 2 weeks in advance. But also we are able to change the price array and see how that estimation will change if we change the price points. So in this particular case, we can get a demand curve estimation for each particular product in each moment in time for each particular store, for instance. And from those demand curves, we can also calculate the profit curve, as I was mentioning before. And also, we also integrated the warehouse information because, as I was saying before, we are doing estimations with forecast with 2 weeks in advance. So we could also integrate and do some proactive integration of the inventory that we have so far. So if we see that we won't have more than, let's say, 20 units, what we did was to truncate the demand curves up to the maximum level of amount of units that we could be selling in 2 weeks from now, given the warehouse information we had. And so once we have the forecasting part of it solved, what we get into is the optimization part of it. So as I was mentioning before, in this particular case, we had one very important business constraint that said that we couldn't give more than 10% discount with respect to MSRP for the whole store. So as we were optimizing 110 products, we had to make sure that we didn't give more than 10% of the overall sales we had. So in that particular case, we have to work with a Bayesian hopping optimizer that we tailor-made with the different constraints and the different with respect to the maximum price and the minimum price we were willing to set. So with this Bayesian hopping optimizer, what we get is the price list of the recommendation of the price that should be set in order to maximize profit in 2 weeks from now for each particular item, and the associated sales prediction for that price list. And finally, as I was mentioning before, as we are doing this forecast with 2 weeks in advance, we can also do some stock replenishment recommendations as to make sure that that amount of units that we are expecting to be selling will definitely be available in the store. So these are the outstanding results I kind of spoiled before. So after the 5 weeks of exploration phase, in which we are trying out prices that have never been tested before, we had an increase of 15% in terms of gross margin with respect to the control store. And after optimization, full exploitation, we observe a 28% increase in gross margin with respect to the control store. So now coming up as to how you could get started. So what I always recommend, and I think this is like especially a very great place as to connect with different people, from business experts to data science experts, because from the machine learning or data science experience, you may bring up ideas on how you can develop this machine learning model, which are the features and how you could encode them. But definitely you need in this whatever price optimization or retail solution with machine learning, you need to get a very good understanding of the business. What are the constraints that exist? What are the drivers of demand? What additional features you may be not including? And be able to mathematically transform that business knowledge into data features or data algorithms to fit the machine learning system. And so finally, how I think we can continue working with this, I'm more than happy to connect and help and share our experience. I was recently hearing the other talks, and I think there's a lot of things in common, and there's a lot of probably of good questions. So I'm here, and I will be happy to connect and continue learning from you too. So thank you very much.
That was great. Thank you, Maia. So we do have some questions here. George asks, hi Maya, interested in learning more about how you did your power analysis. Any tips on setting up one when using difference in difference? One of the challenges George is facing when doing experiments in his stores was creating a methodology that would easily let us understand how much data was needed to detect an impact in their KPIs.
So yeah, definitely. I think that's a really good question. As I was mentioning, kind of the way in which you have to integrate these experiments with maybe some causal inference and knowledge and background. So me coming from the economics point of view, I was pretty sure that a difference in difference approach in this particular scenario was a good fit, because as I was mentioning before, we had this control store and treatment store that were completely independent, but there are a lot of assumptions that you may be sure to be fulfilling in order to be able to do this kind of quasi-randomized experiment. But I can definitely share some more insights in some particular cases in which you may not be able to find these independent groups, so such as stochastic control methods, in which you may define a control group in a synthetic control method, so in a synthetic way in which you are combining different time series. So I think getting into causal inference literature and synthetic control methods may be a good help into defining these experiments in real life.
That's great. Okay, so and for those who are here, if we can't get to all the questions, if you toggle into the people tab, you can find Maya, and Maya, you can check your messages there. There's folks that I'm sure will message you there as well. So next question. Xiao says, I'm curious how you account for competitive pricing particularly when products are available across many retailers. For instance, like bananas or TVs.
Great. So I think that opens us up another good talk to have into what we call internally at Tyrolabs product matching solutions. So obviously, it's way more difficult to match bananas than matching universal items that have a UPC, for instance. So in terms of how we get the competitor's price, we have some other bunch of algorithms that allow us to do so. But mainly what we take into consideration in those cases, it's the images, as I was mentioning, on computer vision techniques, natural language processing in terms of the description we may get from those competitors' items, and also features such as the price. So that may allow us to compare whether or not we may be talking about the same item or not, right? If we are talking about items that are completely off in terms of price, we are probably matching it incorrectly. So we generally think of this product matching solution with these three fields of expertise, and all included in one algorithm. But definitely, if you want to, I can shed some more light into those solutions.
So Kevin asks, can you share again, Maya, quickly your results in profit gain and how you measured that over time?
Yeah, so I may go back to the slide. So in this particular case, as I was mentioning, this was the results for the POC. So those were 10 weeks of experimentation. And so this profit gain, 28% increase, was for those 10 weeks as a whole. So after this POC, the idea obviously was to roll out this and put it into production with way more product categories and items. Unfortunately, COVID hit pretty badly the travel industry. So they are developing this solution by a lower pace. But in fact, it's 5 weeks of exploration. On average, we got a 15% increase in gross margin with respect to the control store. And after those 5 weeks extra of optimization, the whole average of the 10 weeks was 28% increase.
Maya, Josh is asking, conduct.
Sorry?
So Josh is asking, what was the, oh, I lost it. the process of conducting exploration? Was it setting random price drops or increases, or a specific algorithm?
Yeah, so it was kind of an internal heuristic that we figure out with the business experts. So the idea was that we were testing prices that were not exactly the same price that have already been tested before. We included kind of a 5% increase and 5% decrease buffer around those prices. And before doing so, we bucketize those prices as to make sure that we have enough price buckets that could potentially represent the whole price range that we were looking for. So we made sure we had representation of weeks with sales in each one of those price buckets and for a given amount of days. So if we have set that price for only one day, that wouldn't be considered as a valid price bucket, because we had to have at least 1 week of that price being tested on the store. So it's kind of an internal heuristic we try to figure out by trying out prices that have never been tested before, but that could potentially provide information and fit the model for extra experimentation.
Perfect, thank you. We have more questions coming in. Unfortunately, I don't think we're going to be able to get to all of them, but we'll try and get a couple more in. Tab says, love the idea of data scientists translating business knowledge into features. Any examples of this happening that others could learn from?
Yeah, definitely. So for instance, I remember working recently on a project for estimating prices on the real estate industry. So you may have heard about estimating price of houses, that it's all about location, 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 right? So when business expert tells you location is very important, you may think about considering the zip code as a feature and then target encoding that feature. But you may also think, okay, I have latitude and longitude, so I can do some geohashing as to determine, for example, smaller regions that may be representative. So that's how we kind of translate business knowledge and expertise into features for the machine learning problem. That would be geohashing the latitude and longitude, and then doing a target encoding with that geohash of the latitude and longitude.
Okay, great. Yi is asking, hi Maya, can you please, one, expand on the constraints for the optimization problem and the optimization problem itself, and then two, the techniques on building the forecasting models?
Great. So in terms of the optimization problem, so every optimization problem will probably be quite different, because you may have to consider a lot of business restrictions and constraints. So in this particular scenario, we had kind of this big constraint that said that we couldn't give more than 10% discount on the sum of the whole sales for that given store in that particular month. So in that particular scenario, we were making prediction for each week, and we were able to say how much discount we were providing for each particular item. But we have to sum all of those demand curves and all that elasticities into understanding what's the best set of prices to be set in each particular week of the month, so that this whole sum of it wouldn't exceed the 10%. So it's a non-linear optimization problem. It's even non-convex, because if you may have thought about the demand curves do not look very smooth in reality, they may be a little bit bumpy. So we had to include some splines as to make this a convex problem, and also integrate this basic hopping optimizers to find a global minima by exploring some local minimizations. So it really depends on the optimization itself problem you're facing.
Thank you. Okay, so I'm going to try and squeeze these last two questions in, even though they're a little different. Thank you, Jarrett and Brian. So how many SKUs as a percentage of total SKUs were used for testing? And have you analyzed cannibalization of non-impacted SKUs? And then the second one is just maybe a parting. Could you give us an idea of the sort of resources that were required, maybe in terms of talent, like headcount working on this, and then were the software costs? If you could give us as much, I guess, as you can.
Yeah.
Thanks, Maya.
So in terms of resources and in software, it's open source. We did everything on Python, so it was, in terms of computing power, we didn't have much. We did have some instances as to train on the cloud, but it wasn't quite expensive. That it's pretty cheap. And in terms of resources and people, we were 3 people working on this project from our side: data science, 2 data scientists, 1 machine learning engineer that pretty much do quite the same role internally. And then from the client's perspective, there were, I think, 2 people full-time allocated to this project as to do the tests and be sure that all prices could be set properly on the store. So that was one of the questions in terms of cost of the project. We can definitely talk about that offline. And I think there was the other question regarding the number of SKUs. So we were testing this particular POC with 110 SKUs, as I said, all from the same beauty category. And the cannibalization issue was really important. And we were definitely considering as to understand how the items that were not from our particular set of products that we were optimizing being affected, and we saw no difference with respect to the control store on those other items. So we can pretty much confidently say we didn't cannibalize the store. And so we had also this comparison with respect to the control store with items that we were not testing out with.
Maya, thank you so much for that. It was very enlightening. I really appreciate your patience and answering so many questions. I hope we have you back to share again soon.
Sure. Thank you very much for the invitation. I will be here around, so just feel free to contact me if you have any additional questions I couldn't address.
Awesome. And Lucia posted an email where folks can get in contact with you as well.
Yeah.
Thank you so much.
Great. Thank you very much.